students, today we are discussing about linear programming. There are various versions in the case of linear programming. We are discussing today about mathematical formulation. The objective of linear programming is to maximize profit or to minimize cost. The maximization of profit and minimization of cost are subject to certain limitations called constraints. We are developing an objective function. This objective function includes profit or cost as the case may be. The constraints are expressed as inequalities or equations as the case may be. The inequality can be less than or equal to or greater than or equal to. If it is equality, it is equal to. Both the objective function and these constraints are linear relationship with the variables. See, this is the question. We may formulate LPP, that is linear program problem. That is certain equations. From this question, we are developing certain equations. See, we may study the problem. A toy manufacturing company is manufacturing two types of dolls, doll A and doll B. Doll B is a deluxe version, that is doll A and a deluxe version doll B. Doll B is a deluxe version. It takes twice as long to produce A type. That is, one is basic version and one is deluxe version. This deluxe version doll requires twice the time as basic version doll. Then, if we prepare only basic version doll, you can prepare 2000 dolls a day. See, 2000 dolls a day. So, how many dolls? If we prepare only deluxe version, 1000 dolls. Because deluxe version requires twice the time as basic version. Okay. Then, we can develop one equation from this. Another equation, plastic. That is, plastic availability for 1500 dolls. Both A and B combined. That is another equation. You can develop another equation from this. Then, a fancy dress required for this deluxe version. Fancy dress availability only for 600 dolls per day. Okay. So, we can develop three equations from this. One is time, one is plastic, the next one is dress. Before starting this linear programming solution, that is linear programming problem formulation, we may consider profit or cost given in the question. If profit given in the question, our aim is to maximize profit. If cost given, our aim is to minimize the cost. That is the first concept, our objective concept. Our first step is putting name for doll A and doll B. Let doll A be x1 and doll B be x2. Okay. Before developing equations, we may put the products. How many products the company is manufacturing? Only two products. Put them as x1 and x2. A and B as x1 and x2. Okay. Profit given. See, profit rupees 3 and rupees 5. Rupees 3 for x1 and rupees 5 for x2. profit given rupees 3 for x1, rupees 5 for x2. Okay, therefore our objective is to maximize profit. So the objective function is 3x1 plus 5x2. We have to write maximize Z is equal to 3x1 plus 5x2. This is the objective function. This is the first step. See, we may put basic version A as x1 and deluxe version B as x2. Profit given rupees 3 x1, rupees 5 x2. Then our objective function is our aim is to maximize profit. So objective function is maximize Z is equal to 3x1 plus 5x2. Then we may develop constraints. Here we can develop 3 constraints. That is, one is time constraint, and the other one is plastic, and the other one is fancy dress. First constraint, that is, deluxe version takes double the time as basic version. So, if the company is manufacturing only basic version, the company can manufacture $2,000 a day. So, if the company manufactures only deluxe version, the company can manufacture only $1,000. Okay, so the constraint can be x1 plus 2x2 less than or equal to 2000. See, this less than or equal to, the company can manufacture only $2,000 a day if it is basic version. So, below that they can manufacture, not above. So, less than or equal to. See, suppose the company is manufacturing only x2 dolls. 2x2 is equal to 2000. So, x2 is equal to 1000. See, if the company is manufacturing only basic version, x1 is equal to 2000. The company can manufacture $2,000 if only basic version. Okay, this is the first constraint. That is, we are developing one equation from this time constraint. The second equation, that is supply of plastic. Total plastic availability is for $1,500. So, x1 plus x2, not more than that, so less than or equal to 1500. If only x2, 1500. If only x1, 1500. So x1 plus x2 less than or equal to 1500. Next constraint is fancy dress. That doesn't matter, only for $600. So x2 less than or equal to 600. These are the constraints. There are 3 constraints. That is, we are developing certain equations from this problem. Therefore, the LPP can be written as maximize Z is equal to 3x1 plus 5x2. This is the objective function. Then, these are the 3 constraints. It can be written as subject to. No need to write constraint here. These are the constraint. The constraint assumption we are putting here. Subject to x1 plus 2x2 less than or equal to 2000, x1 plus x2 less than or equal to 1500, x2 less than or equal to 600. And also you have to write x1, x2 greater than or equal to 0. That is the LPP. So this is the linear programming problem. LPP formulation.